From DataStax, this is the Distributed Data Show podcast.
I already see some people calling out to us on YouTube. I think we're turning live here shortly. Waiting on one more screen. Somehow I don't think I can hear David. So one more moment, guys.
You might not believe us, but we have done this before.
And I can hear you now.
You can hear me now?
I can. Awesome.
All right, wonderful. Well, that was a fun start to this week.
Hey, you know what? It's just Tuesday. Let's see what happens.
Yeah, it is Tuesday. It is Tuesday. Well, this is, this watching Attic Ladders was also not what I was expecting to have up on my screen here. So let's get back to where I should be. There we go. All right. So thank you, everybody, for joining us in another week with Graph and Code. As I mentioned, with myself, David Jones-Gilardi, and the graph knowledge extraordinaire of Denise, Dr. Denise Gosnell.
It's great to see you again, David. I always love getting to do these live streams. So I'm looking forward to what we're going to get into today.
I totally agree. And I see some folks online. I see that Frank has said I can hear both too. I see a yay.
Thanks.
So I'm hoping that means you guys can hear everything. So that is wonderful. Okay, so with that, why don't we go ahead and, for those of you who, some of you may have tuned in with us 2 weeks ago, right? We did skip over last week, but we did not skip in the material, right? So we started off a couple weeks ago, essentially going through the graph book, right? And I should kind of bring up on the screen. By the way, hopefully you guys are seeing my screen as well. Yes, I see it on the stream. Wonderful. So the work that we are going off of, what we're based off of here, is the work that Denise, Matthias have done on their graph book, their new O'Reilly book, the Practitioner's Guide to Graph Data. And if you haven't taken a look at this and you are into graph databases, or you're just learning, like, how do I apply my use cases? Like, how do I do graph? This is probably one of the coolest and best ways to start on that particular journey. It breaks down, all sorts of ways, like regularly used use cases. It shows you how to do them. And that's what we're going to do. So Denise is bringing me through all this material, right? So a couple weeks ago, we started in the very beginning with chapter 3. And we were actually going through some of the chapter 3 notebook that's in here. But obviously now we're going to start off where we left before, right? So Denise, I'm going to stop talking. And if you want to go ahead and kind of bring us into what's the journey today? What are we going to be looking at?
Yeah, absolutely. So last time we covered your first graph data model and doing some, your first inserts. So if you have a copy of the book or you are looking at it online, we pretty much got through about page 71 last time in chapter 3.
Yeah.
And we're following through the example notebooks that David has pulled up right here on GitHub. So you can always go back and catch up. So where we're going to be diving in today is towards the end of the chapter 3 notebook. So we're going to do 3 things. We're going to review a very common Gremlin pattern. We're going to review the where, join, select syntax in Gremlin. Then we're going to take a look at the main points on when when graph databases are better than relational databases. And then we're going to dive into the select by pattern in Gremlin so that you can essentially save data during your graph walk or your graph traversal, and then select it at the end to start shaping the results of your JSON payload that you want to get back from your database. So that's kind of what we have on the agenda for today. And I'm following comments on multiple places over here. So if you have questions, ask them as you go, interrupt us, we're watching. I'm following them on the YouTube stream in addition to a stream that we have up on Twitter. So multiple places where we're streaming, multiple places where we're getting questions coming in. So keep them coming. So So David, I think where we want to start is kind of back in the notebook where we left off last time.
Okay. And for those of you who are just tuning in, if you haven't already, all the material, everything we're going to be doing is based off of the GraphBook repository here in GitHub. So if you go to github.com/datastax/graph-book, and you'll find there are instructions here on how to get started with, Docker. So I've actually started this all up. I've already got everything running and everything. It is built. This is built to be extremely easy with a Docker Compose up to just go, right? It'll give you some things that you need to know here as far as like resources. You pull down the repo and you do a Docker Compose up, and you can kind of follow along with us if you would like to. And then from there, once you've done that, it will start not only an instance of DataStax Enterprise with Graph, but then Studio. So you'll notice that I'll go to this localhost 9091. That's the default port for Studio. I'm actually going to step back just for a second, Denise. And you'll see something like this, right? You're going to see a whole set of notebooks that are here. Yes. This is all preloaded. It's all already in place when you do that Docker Compose up with that Docker image. And we are here in Chapter 3, Simple 360.
Exactly. That's where we are.
All right. So
the story the story we have is that most people, when they're getting started with graph databases, they usually, when they're thinking about what they want to build, they're typically describing that they have customers and they have data connected to their customers. And they want to use this graph database to go after what we commonly call like a customer 360 application. And the story that we're telling in this moment is that we have, that we're a banking institution, or we're a global bank. And we wanted to be able to answer basic questions like, for this customer, tell me everything that I know about that I know in my system about that customer. And so we set this up with the graph database model. And you can see it if you scroll down. We have our graph database schema up at the top of this Chapter 3 notebook. And you can see here that we have a customer as a vertex label. And then we have 3 additional vertex labels that we've connected to that customer. We have their accounts, their credit cards, and their loans. And so these are the 4 vertex labels that we're going to be walking through during the examples. And then we have 3 edges that are connecting them. So a customer owns an account, or a customer uses credit cards, or they owe loans. So we're going to be using this data model to ask the questions. So let's go ahead and, and Frank, I'm so glad, to your astonishment, that it worked out of the box for you. That's awesome.
Oh, that's awesome. So it sounds like it sounds like, Frank, you went and pulled down the Docker image and loaded that up. That's really cool.
Yeah, awesome. Thanks for letting us know that. Yeah, so what we did last time is we talked about how to answer the question, for this customer, tell me everything that we know about them. And the way I see that, in graph language, I see that as the first bridge on how to understand SQL in graph traversal or graph query languages. So the common pattern that everyone does in SQL is where from select. Oh my gosh, I'm kind of forgetting and tripping on this right now, David.
I'm just going to drink some water while you do that, Denise.
Oh, nice.
I'm going to help you out by drinking some water.
Well, when we look at doing this pattern in SQL, you typically do select from where.
Right.
And when I think of doing a graph traversal, I see it as the exact opposite. I see it as where from select. Mm-hmm. And that's what we started with last time. So let's go ahead and scroll down to the first query.
Are you? Yeah, not the schema stuff, the actual query, like
here?
Yeah,
the actual query, because that's where we left off last time.
Yep.
And so what you can see here is that in this query, that's the first adding vertex query.
Oh, I'm sorry, my bad.
No worries.
Oops. Add.
Yep. So we added all of our data.
We added a bunch of stuff.
Yep. Okay.
Is this the one that you want to see?
So this is where we left off. Exactly. So
there we go. Okay.
There you go. So what you can see here is that this is the data we added into the database last time. We have some customers, we have their accounts, etc. And so this is essentially giving you a whole picture of every piece of data we have in our graph database right now. So we're going to go ahead and we're going to get to our first set of queries, which is the cell below this. There we go. All right. So the first question that we're going to start with is we want to start with asking for this person, customer 0, what credit cards do they use? And we're going to follow this where join select or where from select, depending on how you want to think about it. We're going to follow this pattern to walk through the data. And remember, David, from last time, how we turned on line numbers in Studio? I think it's what, Control L?
Oh, that's right. Done. There's some line numbers for you.
Perfect. Okay. So when you're doing your first graph traversals, the first thing you want to think about is the reverse of that, select from where. We want to start with where. So you're kind of thinking about where you're going to start your gremlin in your graph data. And on line 1, we're saying, let's go to customer 0, and we're going to put one gremlin on that vertex. Maybe I shouldn't be telling you guys exactly how I think about this, because y'all might start thinking I'm a little nutty, but that's how I see it. So on line 1, we said, hey, let's start our gremlin right there on customer 0. And what we want to do is we want to go over to the credit cards, because the question is, which credit cards does this customer use? So we start at customer 0. We walk out the uses edge label. And when we walk out that, it's like you just walked across a bridge. And now you're sitting on the credit card vertex that is connected to customer 0. And we're going to select data. So it says here on line 3 that we're going to select the credit card number. So when I make that statement about graph traversals or these neighborhood traversals being the reverse of select from where, that's exactly what I mean. Where do you want to start? Join all of your edges together and then select some data. And that is the basic pattern to start really, really wrapping your mind around so you can get really good at writing graph traversals.
And so I just want to say this back to you, right? I want to make sure that I have it right. And I was also following along on the schema on the right-hand side.
Oh, yes.
Right?
Yeah.
So here, looking at the schema, I've got my customer vertex, and I'm going to find a specific customer, right? A specific customer vertex by this here with the has and customer 0. And then out uses. So I'm actually going to traverse out over uses in the direction of the arrow. And then I'm going to land on a credit card that is then related to that customer 0. And then in the credit card, they should have a property here. I'm not seeing my properties for some reason.
Not seeing your properties, what do you mean?
Usually when I hover, I don't know why I'm not seeing my properties in this view. I can usually see.
So you on the diagram above, you see where it says columns underneath credit card. You want to go ahead and press that caret.
Oh, that something. You know what happened? Studio's been updated, and I wasn't up to date. I'm used to it actually hovering the thing. Yeah, there it is. So you can see that it's CC num. Right. So then I traverse over uses to go to credit card, and then the property I wanted to get the value of is this CC num property. Yes. Going back to the example you gave before from the regular CQL standpoint, right? I would be doing the select from where I'd be saying select CC num from customer where customer ID equals 0. So this is what you mean by kind of flipping that on its head and saying where join or where from select. Is that right?
Exactly.
Okay. Cool.
Some people like this analogy. I have found that people like this analogy more often than not, especially if they come from a relational background. However, if you have a journey more similar to mine, where you pretty much started your development experience using NoSQL databases, that one might not make the bridge for you.
I see.
So I guess it just kind of depends on your personal preferences. So I think I saw you run that and you got no data return.
Yeah, you know what I think happened? I haven't left this Docker container running with all of its data for the last 2 weeks. And so when I started it up brand new, I believe most of the stuff is in place, but I wonder if I need to add some of the data.
Okay, let's go back and re-add the data.
All right, let's see. I think, I'm doing it, I should probably do this in the right order. Here, let me start from the beginning. Go do. Yeah, a lot of this is already there, and if not exists, but I'm just going to do it just to be sure. I mean, the scheme is already in place.
Yeah, so for those of you who are watching, just to kind of summarize what David realized he needed to go back and do. So last time when we set this up, we had gone through all the way at the beginning, and we established our schema, and then we inserted the data, and we had ended in the middle of a traversal. And when we want to start over every week, we want to make sure that we have the schema set back up, and then we also have all of the data inserted. So what David is doing is he's going back, making sure that the schema is still up to date, inserting the data. And I love that we're doing this live, because this is what it's like when you are trying to develop applications or you're trying to do something new. You kind of have to pick up and drop off intermittently throughout your creation and your development experience. So this is great. And this actually is exactly how I just spent 2 years writing this book, was always going back and trying to remember where I was in the development of these examples. So let's go ahead and give that it looks like you went back through and added all of the schema and the data.
Yes.
And now we can run this query. Is that correct?
Yeah, that's right. So we are getting the data. And just to make that connection, right, you guys just saw me run through a bunch of Gremlin queries and just hit run without really connecting it back. There was a spot up here. We had already had our schema created. That's why we could see the schema over here on the right-hand side. But as far as the data goes, here we go. This is the part now we're starting to add in some of the actual data, right? And you'll see some of the Gremlin traversals that I was running were not only adding, so we've got the schema, we've got our customer vertex, account, loan, credit card, so on and so forth, but we have to actually add vertices with that data and those properties. So this is what I'm doing. So as I was executing these, you see my add v, you'll see that there'll be some edges, add edge, here we go from Michael to CC17. So this is what was missing, and this is what I needed to add in. And now that I've done that, it looks like things are operating as I would expect.
Awesome, perfect. And that's great. I love that we got to do that live, David, because I kind of have this internal conviction that if you're breaking something, you're going in the right direction.
Yeah, right.
So I don't know. I love having that moment live to just demonstrate the fact that you tried something and it wasn't working, and we just kind of figured it out. Because that's what you have to do when you're getting started and learning new technology. You have to go with it and understand and figure out how to translate your error messages into what you need to fix. So that's awesome. Totally. Thanks for showing that. Mm-hmm. Cool. So what we want to do is we want to keep going in the questions, and we want to build up eventually to answering the most valuable question. And the most valuable question that we work with companies around the world to solve is, for this individual customer, tell me everything. And do that with very, very short amount of code. And so that's what we're building to here as we go through these examples. So what we just showed you was from walking from customer 0, how to find their credit card information.
Okay.
We're going to do the same thing, but we're going to walk a different direction. We want to go figure out what accounts that customer owns. And that is the question that we have pulled up here on the notebook. And so you can see the schema on the right-hand side, and you can follow along. So let's take the picture first and the code second. So the picture on the right-hand side, we can see that you're going to start at a customer. And in order to get to an account, you have to walk through this edge called owns. So imagine in your head already, the way we're going to build this query is to start at a customer, we're going to walk through owns, and we're going to end up on an account. So for those of you who like pictures, which is very much me and why I love graph technology, that's what I see in my head. So let's go back over to the code on the left, and let's actually walk through the gremlin that does that statement. And pro tip, line numbers, love them.
Oh, my bad. One of these days I'll get all your pro tips all at once, and you'll never have to say it again. Until then, everyone live gets to watch me.
No, that's okay.
Wait for you to tell me the pro tips.
Yeah, so David, actually, do you want to flip this one? How about you give it a go, walking through the where join select pattern for 1,
Yeah,
2,
let's
3.
do it.
Yeah.
So it looks like here, I'm trying to answer the question, which accounts does this customer own?
Yep.
We're already not aware of the fact that we have a customer vertex, and it looks like we're starting from the same customer as before. So we're answering other questions about the same question or the same customer we had a moment ago. So here we're using our has to essentially do our where. So where in my graph do I have a customer vertex with a property customer ID that is equivalent to customer 0?
Exactly.
So we're starting there. That's my where, right? So it's going to start here with that particular customer. Then I want to traverse out my owns edge. And again, these are directional. So I see my owns edge is in the direction from customer to account, making the relationship from customer to account. Then, and that was on line 2 here. And then on line 3, if I take a look at account, and now I'll do this part right, we see that I have an account ID is a property that is in my account vertex, and I want to get the value of that. So very similar to what we did a moment ago, right? This is actually really easy. So instead of going customer uses credit card, I'm essentially just saying, I want to find the account, what accounts this customer owns account, and that's where I have customer owns, there's my join and account. We see that it's account 14. They own one account 14.
Perfect. That's it.
Yeah, I got it right.
You got it right. Live stream, just figuring it out. For anyone following either live or on the replay, what David just basically said, it was written on page 72 in the book that we're going through. So I don't know, David, if you had memorized that, but that was pretty much verbatim. So thank you.
No, I didn't actually, and I'm going to page 72. Here, we're going to see if Denise has her pages memorized, which I have no doubt that she probably does. Oops, 72.
Well, I am cheating. I have a hard copy of it right here.
Oh, and there it is, though. Boom. Yeah, so.
Awesome.
Yay.
Okay, cool. Sweet. So I think on this next query,
okay,
we wanted to get fancier. We wanted to get fancier with the JSON payload. So far on that last one, you were just returning the account number. And
yes.
Yasser, thank you so much for the question. Can you zoom in a little bit, David, to make your code larger?
Oh, let me see. Well, let me do it. Boop.
Yasser, let us know after he does this zoom here if that works for your.
Is that it? Yeah. Let me know if that's better for you.
Yeah.
By the way, while we're stopped for a second, Denise, I do see a question here from Kamal.
Okay, cool.
In YouTube. Can you please highlight the main differences between graph and NoSQL DBs, such as Cassandra, in which case you pick one instead of the other?
Kamal, that is a fantastic question. The main differences between graph and NoSQL DBs. That's also a very heavy loaded question. So Kamal, what we do have is we have a table that we can actually go to now since David, you still have table 3.2 pulled up, right?
I do. What do you know? Boom.
Cool. All right. So Kamal, what I would like to do is kind of zoom in on this table that we have. It's table 3.2 in chapter 3. Maybe make that a little bit larger if you don't mind.
Yep. I was already anticipating that request. Here you go.
Awesome. Kamal, fantastic question. Yasser said the Zoom is great. So thanks so much, David, for doing all that. The way I like to think about just one specific component of the question that you just asked, Kamal, is from the relational comparison from relational to graph. Now, there are so many different ways to take that question. And I know we have tons of content, but let's just zoom in on one of them for a moment, if you're okay with that. And I like to think about relational versus graph on these three axes. I like to think about it from a data modeling perspective, representing relationships, and then the complexity of queries. And when you go through the relational thought process and then the graph database thought process, the main wins that you're going to get across the board on relational is the fact that they've been around for decades. So when it comes to experience and documentation, relational databases are going to have a lot more documentation out there. So if you're having a problem with a query or trying to understand how to design a schema or optimize an index,
Google your way through it.
It's probably already out there.
Yeah.
So that's one way to think about where relational is always going to win. It's going to be faster to develop with relational right now because the documentation is way better and way more expansive. On the other hand, the reason that practitioners like myself and our colleagues at DataStax and our peers around the world are using graph databases is because of the simplicity that you get when you're thinking about your data in a model all the way down to how it's represented on disk. There's not very many steps of transformation, not as many per se, that you would have when you're doing relational. So let's think about it from a data modeling perspective and then relationships and then queries, talking about graph databases. So when we were doing those questions just a few moments ago, we were able to have a picture on the right-hand side and then write a query that was essentially walking through your data. So when I think about data modeling, I like to talk about how the digital representation of your graph data, it matches how humans intuitively think about their problem and the connectedness of your problem. And because of that, it makes it a heck of a lot easier to model relationships in your data. So if you're thinking about, do I need a graph database? The question I would encourage you to really think about is, do you care about the relationships that exist within your data? Is that the most important part of your problem? If that is one of the most important parts of your problem, then you absolutely are going to want to use a graph database to model it and query it. It's going to simplify that mental model that you have all the way through the technology stack and the persistence you have on disk in your computer. So to me, that's kind of the first 2 points about graph databases. And for the third point here about queries, we were showing you how I've translated, or how we commonly translate, the where join select pattern to teach Gremlin or to teach graph traversals as a way to give you a bridge from the land of SQL. If you think about how massive those inner joins or the left joins or whatever style of join, think about how long that query becomes when you're having to write out all of those join statements.
Yeah.
But yet how beautifully simple and short it is when you just type the 3 characters of out or in, or you do like a more expressive language. That's really where you start to see some benefits. Now, yeah, I was going to say, we do have a few pages back in that book. We do have the join syntax for those queries.
Oh, do you really? Oh, okay. Because I was, a resource I've used before is SQL to Gremlin, which really illustrates exactly what Denise was just talking about. Really neat. Yep. In a neat way. Like you can take some kind of known query patterns and you can compare what does this look like in Gremlin compared to what this looks like in SQL. And when you're dealing with the kind of things that Denise was just talking about, where the focus is on relationships, the complexity of some SQL queries to be able to do the types of things that you can do in a much, much simpler way with Gremlin is, you can really see it in the queries. You said, so if I scroll back here, there's an example?
Oh, yeah. Head on over to page 60 and scroll back to page 60 and you'll see the SQL for the queries that we've been doing.
Really? I didn't realize. Oh, here we go. I went too far. I'll swear. Oh, okay. I see what you're doing. Like, here's an example.
Yeah. So in chapter 3, now we jumped for these live streams. We jumped straight to teaching the Gremlin. But in chapter 3, we went ahead and implemented it in full in Postgres so that you guys could see a comparison side by side.
Oh, that's
so that was page 58. Yep, you can stop right there. So there's one example. So when we were doing the Gremlin, statements.
Don't mind me. I'm going to actually, stop moving around while you're talking here in a moment. I'm trying to
you're trying to show them side by side?
Yes.
Perfect. I love it.
Okay. Gives you an idea.
Yeah, it does. It does start to give you an idea. On the left, what you're looking at here on the screen now is the join syntax for joining customers to O's and loans tables and selecting some data. And on the right, you're looking at the Gremlin syntax for doing something very similar. So depending on how deep you want to go in your relational versus graph comparison, I highly recommend that you head on over to where DataStax is hosting these chapters for free, and you can get the book chapters directly from DataStax. And once I have a moment, I will find that link and drop it into the YouTube comment section so you guys can see it. But essentially, that's what's happening here. On the left-hand side, we're doing a 3-way join. And that's the same thing we're doing on the right-hand side so that you can see how to look at the Gremlin syntax versus the CQL syntax.
And I would actually say this is even a simple example, right? You can get into some really fun, hairy examples. And I know that was somewhat what I had in mind, actually, when I was heading over to SQL to Gremlin. There's some really cool examples out there where they will show you, they will compare them both. I was actually looking to see if there was, I haven't been in here for a while, honestly. Maybe like a left join or something. Right. You'll start to see examples where they will show you SQL and then next to some Gremlin and give you a feel. And as you get into some of the more sophisticated and complex queries and such in SQL, you'll start to see this divergence of what it looks like.
Yep.
Between the two.
Yeah, and then Frank, great question coming in on YouTube. And by the way, depending on where you are watching this stream, most of the comments and conversations are happening on the YouTube stream. So if you want to be answering or asking questions in a place that you know that we're looking, that is where we're looking, if that helps. So Frank had a great question. You seem to be implying that graph queries will be much faster to execute. And that is, I don't know the right word for it, but that technically I know is a trap, because depending on how we want to go into that question,
it depends, right?
There's a ton of landmines there in that in my response of what I can say to that, Frank. But here's what I will say. Depending on how you implement them, most of the time when you're using a relational system, you are joining across the entire table of information and then doing a filter before you specifically walk through just one relationship to another piece of data. Now, if you're a deep user of relational technology, you know how to properly set up your join tables and indexes to avoid that. However, my point is that out of the box, when you are using graph technology and you start with just this one customer and you walk out their edges to their respective joined pieces of data, that's going to be the fastest way to query just the relationships that are important within your data. So the real answer, once you get down to the design and implementation of relational versus graph, it really comes down to whether or not relationships between pieces of data are the most important concepts that you have and that you need to store and query for your database. So it sounds like, Frank, maybe one day if I ever have the chance to meet you in person, we could have a really fun, long debate about the implementation of each of these systems. But that's how I see it. Hopefully, Frank, that was helpful. And I provided a link to all of our thoughts on this topic that we have for free in Chapter 3. So thanks so much for asking questions. And Kamal, let us know if that was, it looks like Kamal said, thanks so much for taking the time to explain these differences. Awesome. If you have any more questions, keep coming. Love them. So I love it when you guys ask questions as we're doing this. Okay, so before we went down the kind of zooming back up, we were doing some queries, and then we went down a planned detour into the differences of different types of databases. So we're coming back up now, and we're going to get back to learning new query skills for working with graph data. Sound good?
Sounds good to me.
Neat. So what we were doing at this point is the last query we had, we started at customer 0. I think we walked out to their account and then just grabbed their account ID, right?
Right. And yeah, matter of fact, that's really more like this.
Exactly.
Right? Except we're not getting the property of the account ID at this point, because it looks like we're going to do something a little bit more here. Exactly.
And I think that's the first 3 lines, right?
Yes.
Lines 1, 2, and 3. Okay.
Oh. There's some line numbers for you.
Thank you.
Yeah, because I totally read your mind without you having to at all give me any indication you might want.
Just a gentle prompt, but thanks. I don't know. I can't get around writing code unless I have line numbers, so it just is very helpful for me.
I'm with you.
Oh, thank you. Okay, cool. So here's what we want to do. Usually when you are implementing databases and you're building up APIs within your internal services, there's traditionally and very often there's some type of language that you end up writing and developing for your team, and it essentially becomes like the JSON expected guidelines of how you're going to share data between applications. So it's great and useful that we know how to walk through graph data, but it would be much better if we were able to build more robust payloads, or to actually start to enforce the fact that you want this query to return data in a certain JSON structure. And so that's what we're doing here at this example. We want to do the exact same query. We want to start at customer 0 and get their account information. But now we want to start enforcing certain structure to the JSON payload that's going to come back from this query. And that's what's happening right here. In order to enforce that JSON payload, what we needed to do is we kind of needed to label, or in my mind, as I'm walking through my graph data, leave breadcrumbs, if you like, Hansel and Gretel stories. But you need to label or leave breadcrumbs as you move throughout your graph data so that you can recall where that information was and pull it forward into your result payload. And that's loosely how I explain this or think about it in my mind. But let's actually walk through the code.
Okay.
So on line 1, we're doing the same thing. We're starting with that reverse idea of where join select. So we're telling our Gremlin traverser where to start in the data. Start me at customer 0. So all of you, as you're thinking about that now in your mind, kind of imagine that you're standing on one vertex in your graph. It's customer 0. What you're going to do is you're going to go ahead and label that, or leave a breadcrumb there. And you're going to put a label down and says, this is my customer. That's what's happening on line 2. At that point, you're going to walk away. You're going to walk away from the customer, and you're going to walk through the owns edge, and you're going to stop now on an account. So now we're on line 4. And now that you're on that account, you're going to leave a label on that vertex, and you're going to call it account. At this point, we have 2 labels that you've left in your data. You've left a label on your customer vertex, you walked, and then left a label on your account vertex. Now what we want to do is we want to do a select by, or we want to actually create some shape to the JSON that you're going to return from this result. And that's what's happening on line 5, 6, and 7. So on line 5, you're going to say, I want to select the customer and the account label. So now you've selected 2 labels. Line 6 is what you do to the first label. Line 7 is what you do to the second label. They're applied in a round robin fashion. Okay. So select customer. And then on line 6, you're going to do what is written on line 6 to your customer label. Now, remember, we stored the customer label on the customer vertex. So it's valid from our data model to say, well, give me that name. That select by now essentially select the customer by their name. That's what's happening between line 5 and 6. Sound good, David?
Yeah. Yeah. And keep going. Keep going. I was kind of highlighting as you're doing it to see if I've got that right.
Yep, you do.
I do have a question in a moment, but I'll let you finish.
Okay, cool. So the second part of your select by is to remember that you left a label on your account vertex. So you're going to say, I need to select that label. And now you're going to go to line 7 and you're going to show that label by account ID.
Okay. So here's my question. Oh, I'm sorry, Denise, go ahead.
No worries. Yeah, the thing to remember here is that when you have these select statements and then you have your by modulators, which that's what they call it in Gremlin, by modulators. These by modulators are applied round robin to your elements in your select statement. So the first by modulator goes to the first thing, the second by modulator goes to the second thing, and that keeps going until they run out or they start over at the beginning. With that, that's how you get the nice JSON structure you see at the bottom. So you see that customer is then associated to the name, and account is associated to your account ID. And you can see that in the JSON below. So
if I added a third, one in here, let's say that I also wanted to get some loan information or a credit card or something like that, I would obviously have to traverse to that. But then as long as I created this as this label, this breadcrumb, then I could also add that in here. I could add another by value to get at one of those properties and would essentially round robin 1, 2, 3 to that third vertex I put in if I had gone through that process.
Absolutely. And in chapter 4, we create deeper, we add another layer around this data. We add transactions that are like sharing data or sharing essentially passing account value to and from your credit cards and your loans and your accounts.
Okay.
And then we do start getting fancy with like, I need to leave multiple breadcrumbs or I need to have multiple pieces of data and make really complex JSON structures. That's coming up in chapter 4, but not yet for this. I want to keep it in the, keep us in the shallow water here for the.
Got it. So something so here's the actual question I had. I want to see, can I get both of these on the screen at the same time? Kinda. Yeah, I can. Okay, cool. So originally when we were starting at customer 0, we were traversing over the owns edge, going to their account and getting their account ID. Okay. Now in this example, we're starting at customer 0 again, and then we're setting that breadcrumb, right? Let's just pretend for a second I didn't do that. But then I go customer 0, I go out over the owns edge, I'm getting to the account vertex, their account vertex. And if I would have tried to do this select like this with customer account, but I didn't set those breadcrumbs, that wouldn't work, right? I need to have that reference created. So if I'm going to use the select as a true statement, I need to first have my as or set those labels, set those breadcrumbs so that I can then access them later with my select.
Exactly.
Okay. I just want to make sure I had that part right. So this essentially means that, and I think it sounds like you're alluding to in chapter 4, we're going to get more to this, that if I had even more complex traversal that went deeper and deeper, that I could actually use as with select to essentially get to a previous point my gremlin was standing on, even though I may be in a different point in my traversal later.
Yes.
Okay, cool.
That's one way, but yes.
Okay, neat.
Cool.
Alrighty. All right, so I just want to, yeah, we have the data I would expect. Okay, cool. All right, should I move on?
Yeah. And I think that this actually brings us to our last example in the chapter.
I know. I feel like we're going to make it to chapter 4 today. I'm so excited.
Yeah. And I want to make sure I didn't lie. Is this the last one?
No.
Yeah.
Right,
So,
yeah.
Yeah.
We're close.
We're close. I mean,
We're
so
close.
Essentially, I think that's one of the main final concepts, because we essentially do the exact same thing now, but we just do it again with a different section of the data.
Oh, right. Now we're looking at, instead of customer 0, we're looking at customer 4.
Yeah.
But this time, though, we're trying to get their loan, right? Okay, or whatever loans they may have.
Exactly. And we've done it. We've walked from the customer to their credit cards. We've walked from the customer to their accounts.
Right.
So the last thing to really look at is how you walk from the customer to their loan. And then after that, how do you just start at the customer and go anywhere and tell me everything? So that's kind of the direction these queries are going. So we start back at the beginning and we say, hey, start at this customer, walk out the O's edge and get back, go to the loans and give me the loan IDs. And,
oh, yeah, right here. Okay.
Yep. And that just reinforces that same pattern of where, join, select.
Right. Right. And I think too, having another, I'm just seeing this for the first time, honestly, having another example of a different customer doing the same thing. It's like, oh, okay, simple enough, right? I just want to pull a particular customer at a particular ID. There you go. So now I'm starting at customer 4, not customer 0. And this is actually pretty simple to follow, right? I feel like these traversals, I can just follow out these edges right to the other vertices. And now in this case, I happen to have multiple loans, right? It's not a single loan. So you can see that now I'm actually pulling back all of those properties because there are multiple loans. So that would actually mean then, if I've got this right, that in this case, and I think this is something neat about graph, and we've kind of talked about, I think we talked about this last time, where here I have the single customer, but they actually we're walking out all O's edges, correct? To all instances of loan vertices that this customer may have. So would this be representative of 2 different loan vertexes that are joined to customer 4?
Correct. And it's not, I also want to make sure that I don't need to, language is hard. And you're only walking through 2 O's edges, not every O's edge in your entire database, just 2.
Right. Right. And is that specifically because we start with our where, and there's only 2 O's edges from customer 4 to begin with?
Exactly. And that's actually a really good point, because that difference in thinking about your problem is one of the main areas to start to, if you can see that, that's one of the main areas where I start to see people commonly understanding, oh, that's why graph is faster. Because we're just going to customer 4. And we're only considering the 2 edges that are connected to customer 4, not the entire edge list.
Right, because you're filtering first and then going from there. You're not starting by walking and then filtering after the fact.
Correct. Yep.
I see.
Yep. And so then this really brings us to like the big aha moment of graph, in my opinion, for this last query. What do we know about this customer? This is starting at customer, 0 is that? Yep.
Yeah, 0 again.
And what this is doing is that it's starting at customer 0 and it's walking out all edges at the same time that are connected to customer 0. And then it's getting you all of the data about everything connected to customer 0. So if you are watching this now or on a replay, think about how you would join all 4 of these tables of data together in SQL.
Yeah.
You would need at least 3 separate inner join statements. And that statement actually is, we don't need to scroll back into the book, David, but if you do want to see it, it is on page 60. And it shows you how you have to bring together 5 different left joins in order to make this work in a relational system. Yeah, so it should be just a few pages below this one.
Okay.
Oh, yep.
Here it is, right?
Yeah, it splits 60 to 61. I couldn't get it to be on one page.
Oh, yeah.
Sorry.
I think we get the idea, though. Yeah, exactly. Okay.
Yeah, so the exact same query we're looking at right now of show me everything about my customer is the same relational query that split 60 to 61 that we're looking at right here. Yeah. I don't know. I would much rather use the shorter version. But
Yes.
I also do know that my brain, for some reason, just likes the Gremlin query language, or the idea of walking through your data and having a very expressive style of query language for it. But that exact same thing is what's happening right here. Yeah, go ahead.
Yeah, and honestly, I feel like this is very powerful though, because I mean, most of us who are doing this to some degree, right? We've probably spent years in SQL, and I've spent 20-something years, right, doing stuff with relational databases. So this is a very, very familiar nomenclature and syntax and such. And to do that, I feel like though, looking at the difference between having to explicitly put in my left joins and that kind of deal compared to just saying out. And once you understand, right, like I've got these out edges and that there's this relationship between the customer vertex and the rest of these, I find this to actually be quite powerful, that I can just say, okay, give me all of those out. And then that's it. And I can just get that data.
Right. And I mean, now any computer scientist who's following this knows that like this work didn't just disappear, right?
Yeah.
When you set up, So instead of doing the work of connecting your data together on query, graph databases connect your data together on disk at the schema level. So it's the combination of your graph database with an expressive traversal query language that allows for the simplicity that we're looking at here. Yeah. So the work still exists. You handle it when you set up your schema, and you handle it when you write your data into the database, so that your reads are much easier.
Yeah. And, matter of fact, I noticed that Frank over on YouTube mentioned the shorter version scores on readability makes debug easier.
Yeah.
Totally. Right. I think this is a lot easier to grok. This is, once you understand this pattern, it's a lot easier to grok than having to read many, 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 many lines of SQL to understand the relationships between your data.
Absolutely. And Kamal, fantastic question about efficiently handling pagination in Crumlin. I have a resource for you. I'd love to point you towards how we do pagination using Java, I believe is the example that we have, to show you how to do that. So Kamal, if you want to connect with me on Twitter or send me a DM, or whichever way is easiest for you, I'd be happy to point you in the right direction to show you how to do that and have a discussion offline. Because it's a fantastic question. I think though, right now we're in like, 6 to 12 inches of water and you're in like 10 feet in the deep end. But I love where you're going. So let me come join you over there, and I'd love to help you out.
Don some snorkel gear.
And ironically, I think like the first themes that are connecting together where you are in your examples in this book relates them all to learning how to train, learning how to scuba dive, and where you are in the depth of water.
What's kind of funny about that is I have a closet full of scuba gear, because both my wife and I are scuba certified. My wife actually is an instructor. And in my mind, as you were saying that, I was having this terrible joke. And you guys on chat can tell us if you really want us to do this. As we get further along these chapters, we just start donning more and more snorkel and scuba gear until we're like fully scubaed out,
What's really funny, David, is that I was a swimmer in college, and so I'm pretty sure I have flippers and like at the ready. Awesome. So that this actually is a good starting point. If you want to fire up the notebook for chapter 4, we can show people where we're going next week.
Yep. Do I want to do data generation or neighborhood DSDev?
Neighborhood DSDev.
Okay.
Neighborhood DSDev.
So we already have the data generation part in place, correct? Because
we do.
In the Docker image, you guys already preloaded it.
We do. Yep.
Okay.
And so next week we'll talk about the difference between those chapter 4 notebooks. So if you kind of caught that and going, wait, what's happening? Don't worry about it. We'll cover that next week. But here's where we're going to go. So the idea of this neighborhood exploration or customer 360, like it's the most common place that almost everyone starts when they're using graph technology. And so in chapter 3, we spent a lot of time, and we basically spent 2 episodes now in this live stream getting set up and walking through chapter 3. So at this point, we have a really good idea of when relational systems are better versus when graph databases are going to be better. Hint, if relationships are the most important piece of your data, the answer is graph databases. And we've kind of walked through and started to understand how you can think about Gremlin with the where, join, select syntax. From here, we're going to add a whole nother layer of data into our data model, and that's what David can kind of scroll a little bit and show us here on the screen.
Okay. think that's the whole thing. There we go.
Yes.
Get it right there.
So this is the story that we're going to start with next week. So now we've expanded a little bit out from the idea of having your customers and just like their basic bank account information. And now we want to start to model this idea of transactions and transactions that are coming from your account to your credit cards and your loans. Maybe you are paying off your credit card with your checking account, or you're using your checking account to pay a loan. And also your credit cards have these transactions when you went to shop at Nike or Target or any other type of store. And so we have all the data loaded into the system so that we have lots of transactions and a lot of data to start walking through and practicing different ways to shape your results so that you have consistent JSON payloads and other types of checks and guarantees. Kind of like thinking through like the try except patterns or if then else kind of patterns when you're writing Gremlin. That's where we're going next week, but with the bigger data model, more neighborhoods of data, and a little bit more data in the back. So
cool. Okay, so Denise, do you want to stop there as far as like the material, or do you want to go on and because it seems like a good stopping point to then start up again next week?
Yeah, I do. Let's stop here. Okay. And then next week, we're not going to get into loading data yet because I do just want to keep practicing and thinking about neighborhoods of data. And I want to just kind of keep going through and reiterating how you work through traversals so that we're getting the bigger picture or the foundation set of how to use graph data, how to think in graph data, and how to answer higher valued questions, thinking about relationships. And so we're going to keep doing that. And once we get to chapter 5 is when we're going to pull the covers back one more layer down and show you how to use partition keys and Cassandra to load your data in with DS bulk and do some of those more performance optimized aspects that are happening here, but we're kind of skipping over those details right now. Does that sound good? Oh no, David, I happen to not be able to hear you anymore. Yeah, I think they're gonna work on getting that fixed because I can't hear David. So maybe you guys are still hearing me here, but it looks like once we switched, we lost audio. But I can hear you again now, David.
Oh, good. Okay. I don't know what happened there, but what I was going to say is just as a quick follow-up for those of you who've been following along. If you want to take a look at this material yourself, if you go to github.com/DataStax/graph-book. And if you follow the instructions here in this Docker Quick Start, it literally takes a moment, and you can have the whole setup running in Docker with all the data preloaded and everything. You can start walking through these notebooks yourself. You'll find that the notebooks, even though we're going through them, they do a really nice job of like explaining everything as you go. So it's really quick and easy, and it's a nice way to start exploring.
Yeah, and Kamal, Frank, you guys were asking some amazing questions today.
Yes.
So if you are comfortable with it, I have extra copies of this book here with me right next to me. Ooh. Send me an email if you would like a free copy of this book. I will send it to you if you're okay with that. I would have to then know an address to reach you, but you're comfortable. I left my email in the YouTube comments, and you are welcome, Kamal or Frank, to send me an email, and I will send you a book.
That's awesome. Man, I wish you'd send me a book. Come on. Jeez.
I can send you a book too, David.
And with that, honestly, for any of you who are listening right now, whether it's myself or Denise, if you have any follow-up questions, anything else, come reach out. We're all over social media, as Denise just said. We're on LinkedIn, we're on Twitter, we're out here. If you ask pretty much anyone from DataStax, we'll get you to the right people. So feel free to please come out and interact. And with that, why don't we go ahead and close it up? Thank you again, Denise, for bringing me through this. I learned all sorts of new stuff. And I'm excited to get into chapter 4 next week. And thank you, everyone, for tuning in for another Graph and Code with David and Denise.
Awesome. No problem. Thanks, guys. Have a good day.
Thanks for listening to the Distributed Data Show. Please subscribe with your favorite podcast app, give us a rating, and don't forget to share with your colleagues. Thanks for listening to the Distributed Data Show. Please subscribe with your favorite podcast app, give us a rating, and don't forget to share with your colleagues.